All right, I'll begin. Dear Father, we thank you for this day we have just to talk about your creation. And I thank you for these students. Thank you for the weekend that's about to start. Help us to learn what we need to from this class and just to glorify you, Lord, in what we do. In your name I pray, Lord Jesus. Amen. So I have these two examples picked out. But before I dive into those, if there's any question, you can ask.
Oh, yeah, 8. I looked at it and I was like, why are you deriving it? Like, I didn't understand.
8?
In the homework, question 8. Pretty sure.
8.5. 8.5 number 8?
Yeah.
Okay, so there we have 1 over x times x squared plus 1 squared. And you're supposed to find the partial fractions decomposition. So here's the deal. You look for a over x plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 quantity squared. Now, I think I'm supposed to actually work it out for that homework problem, right? So let's do that. So we had to do some algebra to figure out what a, b, c, d. I guess e. I don't know why I jumped to f. Not that it matters. These are just unknown constants we have to figure out, right? So if you multiply both sides by the denominator, what do we get? We get 1 is equal to a times x squared plus 1 squared plus bx times x squared plus 1 plus dx, oh, I'm sorry. There's a plus c there. All right, and then plus dx plus e times x. Because everything that's in the denominator, when you multiply through, cancels, right? But what's left over is everything that's not in the denominator, right? So like, you multiply by x times x squared plus 1 squared times this, the x cancels, but it's left with this, right? This one of the x squared plus 1's cancels, but we're left with an x and an x squared plus 1. Over here, when you multiply this times that, when you cross multiply, right, you're only left with the x. Does that make sense? I mean, this is not a step you should memorize, it's a step you should understand, right? But it should almost be effortless to you after you do a few of these. Now what then? Well, this one's kind of unpleasant to actually work out the algebra for. There's some pretty low-hanging fruit here. I can put x equals to 0, right? What's that tell me? This is gone, and that's gone, because there's multiplication by 0 in both of those, right? And what does it tell me? It tells me a times 0 squared plus 1 quantity squared. Okay, so a apparently is equal to 1. All right, 20% of the algebra is done. Woohoo! Right, now we've got to figure out the other 4 things. How do you do that? Well, here's what I would. What's that? Pick it. You could. Yeah, that is one approach. You could just pick numbers, but that will what that will end up doing to you is it'll give you messy equations that you have to solve. So if we can come up with something sneakier, it'd be better.
Could you like plug the a in and solve for like a different number?
Well,
Number, letter?
there are 2 main approaches here. The one would just be to multiply it out and to equate coefficients. All right, that's probably a pretty standard approach. Another slightly more exotic approach would be to plug in the root of x squared plus 1, which is what?
1.
No.
Negative. No.
If I want x squared plus 1 equals to 0, what do I make x equal to? Yep, I. So if you're willing to do that, that gives you some pretty easy equations. For example, if I put x equals to I, we get 1 equals to See, x equals to I makes this 0 and makes that 0, right? And it makes this over here d times I plus e times I, which if you multiply out, that's I squared d plus IE, also known as minus d plus IE. So there's one equation. There's another really easy equation to get from plugging in imaginary things. The other root is minus I. That's pretty easy to do too. That also gives me 1 is equal to, this time, minus di plus e times minus I, which gives me I squared d minus IE, which is minus d minus IE, equals to 1. So if you look at these equations, let's call them 1 and 2. Those are not too bad to solve. What happens if you add them? If you add these, IE and minus IE cancel. What are we left with? Minus 2d equals to 1, right? So therefore, yeah, d equals to minus 1/2.
Add the equations, you add 1, 2.
Okay, so you're saying if I add what? Oh, I get a 2. Yeah, I'm sorry, I can't add. Thank you. D minus 2d equals to 2. Yes. Oh, that's better. D is minus 1. Thank you. Very good. Much better. And then how do you figure out what E is? If you subtract the equation, what's that give you?
Negative I, 2IE equals 2? Oh, no, it gives you 2IE equals 0.
Oh, good. I was worried. I was like, oh no, we're going to get a complex coefficient. But no. Phew. Worried for a second there. But this says what? Divide by 2I equals 0. So, are you guys comfortable with doing what I just did in purple? Can you do a little bit of complex algebra? What are the rules for complex algebra? I squared equals minus 1. Proceed as usual. That's kind of it here. Is that too much to learn? I don't know. It's up to you.
So that, wait, no, we're not done.
No. So but you know, that's great, but there's still two other constants, right? So the usual way people do these is to like multiply things out. It's a little bit awful, but here goes. So this is a times x to the 4th plus 2x. My goodness, this problem might take me a whole class period. 2x squared plus 1. Golly. Plus, I'm going to partially multiply this out. Bx plus c. You don't actually have to multiply the whole thing out. You just have to multiply it enough so that you don't miss stuff. X cubed plus x. I'll show you what I mean in a second here. And then finally, that last thing was what? I got a dx squared plus ex. Right. With that, if you don't mind, I'm going to... Did you already get what's in purple? Okay. I'm going to erase the purple part if you guys don't mind. Again, you can do that if you want, and I think it's faster than what I'm currently doing. This is faster to get those things than what I'm doing. If you're uncomfortable with it, that's okay. But you should understand what I did in purple is the fastest way to get those.
Just those, like, helping get C's, right?
No, not yet. So here's other ways you can extrapolate. You can get equations, and we could do what he said. You just plug in numbers, right, and that gives you equations. You can solve them. You can do that, but that typically gives you awful equations that are hard to solve. I'm showing you how to get equations that are reasonably easy to solve. So what we're about to do is called equating coefficients. Okay. We have two polynomials, right? The reason this didn't come up last class is none of the problems that we worked out were hard enough to need these techniques. All right? So equate coefficients. On the left-hand side, I have 1. But 1 you could rethink of as 0 times x to the 4th plus 0 times x cubed plus 0 times x squared plus 0 times x plus 1. Right? So, if I look at the coefficients of the constant term, what's that give me? This is going to be kind of disappointing, this constant term. On that side, I get 1, right? On this side, what's the constant term? Multiply this out. Don't actually multiply it out. Just think about it. A, right? Is there any other way you can get a constant here? Nope, this has got x's, this has got x's. That's the only way you can get a constant. When I was younger and more fond of just writing like a madman, I would feel the need to multiply this out. That's foolishness. Because in the process of writing that out, you're very likely to make a mistake. The more writing you do, the more likely you are to make a mistake. Everything you write is a chance to make a mistake. So you have to be, it's better to use more thinking. I don't know, there's a balance to be struck here, but coefficient of x. Over there, 0, right? How about over here? What's the coefficient of x? Look at this term. X to the fourth, x squared, constant, no x in here. How about this one? Now I got to do some thinking. This is a little bit dangerous. Oh yeah, c times x, right? So I get c. Is there any other x's in here? There's like an x to the fourth, there's an x cubed, there's an x squared. Oh, and then plus e. Aha. Well, that's nice. Apparently c is equal to minus e. That's nice to know, but doesn't help us too much. The next thing down the line is x squared. How do we figure out x squared? Well, over there, boring, 0, right?
2 and b, d.
Let's see here. So you got 2a, right? 2a. And you said plus b? Plus d. All right, now we got it. Now, of course, that implies what? That b plus d is equal to minus 2a, which is minus 2. Among other I mean, you could package it however you like, but that we have that, right? How about x cubed? We got 0 on the other side, right? X cubes. None in here. Oh, you guys got plus c? All right. It's kind of fun once you understand, right? Oh, c equals 0. Therefore what? Therefore e equals 0, right? Now we found that e equals 0 before I erased it in the purple, but there's some confirmation without this imaginary number. Ooh, sorry. Imaginary numbers are no more imaginary than real numbers. This is a very unfortunate terminology. Let's see here. Anyway, x to the fourth. There is no x to the fourth coefficient over there, so you got 0. On the other side, you got what? A, B, anything else? All right. So therefore, b is equal to minus a, which is equal to minus 1. So there you have it. Well, maybe we have it. I don't know. We found a is 1, b is minus 1, c is 0. Oh, what's d then? Minus 2 minus b, right? Which is minus 2 minus a minus 1, which is plus 1. So d is minus 1 as well. Is that what you guys said? Is that what we found? Hey, that's what we found with the imaginary work. Okay, so all together we have this. X times x squared plus 1 quantity squared is equal to 1 over x. What was b? b was minus 1 plus minus x. c was 0, right? So I'm going to rewrite that as minus x over x squared plus 1. And then what else we have? d was minus 1 minus x over x squared plus 1 squared. And there you go. That is the partial fractions decomposition of 1 over x times x squared plus 1 squared. Es bueno. All right.
So all like the wait, then in the like the solutions you had on there, right, it said like d dx between each of them. Does it just like something you just did? Like, is there another way of doing it, or like that?
Yes. Let me. Sadly, I do not have my computer with me, so I would just put it up there and look at it. Maybe I can do that. Monday's our quiz, isn't it? Anyway, let me do that technique here. I'll show you what that was about. So this one, what would the partial fractions decomposition be for this? So you said something like a over x plus 1 plus b over x plus 1 squared. Yeah, and then plus c over x minus 2, d over x minus 2 quantity squared. Yeah. So the next thing we do is we multiply by the denominator. This one is going to be better to show you what I was doing in that problem. I mean, I'm not sure what I was doing in the solution there is optimal. I don't know. This particular problem is just ugly. So it's not a great place to try to learn a technique. This one's better. So here, we'll see in a second here. Oh, I'm sorry. X plus 1 times what? You guys tell me. There's also a what here? X minus 2 squared, right? Because there's none of that here. And then oh, thank you. You guys are keeping me honest. I like it. Let's see here. So, I remember there's a stupid nomenclature that I like, and I think it's fun. So what I do, if I recall correctly, is I think I want to say I'm going to call this whole thing Pac-Man. All right. So basically we have Pac-Man equals to 2x minus 1, right? So what happens if you feed Pac-Man minus 1? Well, this, of course, is 2 times minus 1 minus 1, right? Let me just simplify that. That's what? Minus 3, right? But what happens when Pac-Man eats minus 1? This is 0, 0, 0, right? What's left? So it looks to me like we can see from that b is equal to what? Minus 3/9. What's that? What have I done? Oh, you're saying it's minus 1/3? Oh, yeah. Thank you. Sorry, it's been a long day. All right. Now, this problem is still slightly ugly, but the thing to do then, of course, another easy thing to do, of course, would be to what? Feed Pac-Man what? 2, right? So that would be equal to 4 minus 1, also known as 3. And when you feed it 2, gone, but that's 9d, right?
Here we're just plugging in numbers.
Yeah, so far. The cool thing, though, is whenever you have a repeated root, one way you can find your way to nice equations is to take the thing you're trying to solve and differentiate it. Right? So, like, what happens when you differentiate Pac-Man? Pac-Man dx. Or if you like, Pac-Man prime. On the one hand, it's equal to 2, right? This guy. On the other hand, and this is a little bit of a mess, right? But let me just do a one step before I do the differentiation. Let's just make our life a little bit easier. We can pull out an x minus 2 quantity squared, right? And this is times what? A times x plus 1 plus b, right? And then over here, I can factor out x plus 1 quantity squared, right? And what's that leave me with? C times what? X minus 2 plus d, right? Because I know where I'm going, like I'm going to evaluate at minus 1 and at 2. It's helpful to just factor those out. All right, so like, what happens? I'll write this out. So that's 2 times x minus 2 times the thing in brackets, a times x plus 1 plus b, right? Plus x minus 2 squared times what? A. Plus 2 times x plus 1 times the thing in brackets, plus x plus 1 squared times c. I did the product rule 2 times. Now, once you guys are caught up with me, what are we going to feed Pac-Man prime? Nice one. So that gives us 2 is equal to what? So the cool thing is, this stuff, gone, right? This piece, kerpsploot, and we're just left with 2 times minus 3 times b plus 9 times a. Because that's a minus 3 squared, which is 9. But we already know what is 9a equal to. Or do we know that? We don't know that yet, do we? We know what b is. So let's solve this for a. A is equal to 2 minus 6b divided by 9, right? I should probably make that a plus 6b, right? I know you guys are going to correct me in a second. B is minus 1/3, right? So what's 6b? What's minus 6 over 3?
No, 2/3. What?
Oh, 2 minus 2.
Minus 2. So we have 2 minus 2 over 9, right? Also known as 0. All right, Pac-Man prime. Feed it 2. We get 2 is equal to what? So gone, gone. This is 3. 2 times 3 is 6. And then times d, right? Plus 9c. So we knew d before. We can solve for c. C is equal to 2 minus 6d over 9. What was d? D was, is it 0 again?
1/3.
6 over 3 is 2, though. It's 0 again. Well, this is very unsatisfying, but there it is. So apparently, this integral is equivalent to doing the integral of, what I got? B minus 1/3 dx over x plus 1 quantity squared. That's my b term. And then my d term, what was d? Dx over x minus 2 squared. So you can read that. That's 1 over 3 times x plus 1 minus 1 over 3 times x minus 2 plus a constant. There you go. There's the integral. I pulled the third outside. I pulled the 1/3 outside. The point is the 2x minus 1 over x plus 1 squared times x minus 2 squared is equal to 1/3, well, minus 1/3 times 1 over x plus 1 squared plus 1/3 1 over x minus 2 squared. That's the partial fractions decomposition. When you integrate, you get to minus, and the third just rides along. Moral of the story, folks, is like if there's a repeated factor, it requires work. I mean, there's kind of no way around it. You either got to like differentiate and plug in, or multiply it out and equate coefficients. But one way or the other, there's work to do. I mean, it's not. Distinct roots are so much easier. This one's kind of a mix. Other question about homework though? Do you now know what I was doing with the differentiation now that I show you this? So in that problem you asked me about what the ddx was, what I was doing was I was differentiating the equation so I could plug in the value again. Any questions? So this one here, this one's a little bit, what I did was I took example 3 in the book and I made it slightly harder by multiplying the denominator out. So like, can you factor that denominator? Ooh, what if I can factor an x squared out of the first two terms, right? And then I've got, remember factoring by grouping? So what we have here is really x squared plus 1, right? Times x plus 1. So what would the partial fractions that we'd be looking for here? Any questions about that last example? I know some of you are still catching up with me. Still catching up? So somebody help me out here. What do I do next? I do what?
So a over x squared plus 1.
So ax plus b. If you're going to do that one first, I'll do ax squared plus b over x squared plus 1. Take care of this. And then what?
Then c over x plus 1.
C over x plus 1. So multiply both sides by the denominator. What's that give us? The correct answer is not a headache. Let's see here, x squared. The correct answer is an opportunity to do algebra. Let's see here. It's equal to ax plus b times what? Times x plus 1 plus c times x squared plus 1. So, tell you what, I'm going to call this thing Pac-Man. If I feed Pac-Man minus 1, on the one hand I get 1 minus 5 plus 2, which is otherwise known as what? minus 2, right? On the other side, I get what? 2c, right? c is equal to 1. I mean, I did that on purpose for your learning. All right. Pac-Man has an imagination, so we'll feed him I. And that gives us I squared plus 5i plus 2 is equal to what? ai plus b times I plus 1. That's 0. This is what? So we get minus 1. I got 5i plus 1 is equal to, multiplying this out, that gives me ai squared. I'm sorry, what you doing here? So I times I plus 1 times a plus 1 plus I. Is there a question? What's going on? What do I do? Okay. So, I mean, you could simplify this a little bit, right? This is minus 1 plus I times a plus 1 plus I times b. That's about all I can do at the moment. So there's that one. And if I feed Pac-Man minus I, what's that give me? I squared minus 5i plus 2 is equal to, well, a times minus I plus b times 1 minus I, let's say. So over here, this gives me 1 minus 5i. On the other side, I get, let's see here, I'll do another step here. So I get minus I plus I squared times a plus 1 minus I times b. All right. 1 minus 5i is equal to minus 1 minus I times a plus 1 minus I times b. So if I call this equation 1, if I call this equation 2, what does that give us? See, if we take 1 plus 2, what do we get? What happens when you add these equations? You get what? 2 equals what? What happens when you add the a terms? The i's cancel, right? We get minus 2a. What happens when you add the b terms? To be or not to be? To be. Sorry, that was awful. All right, 1 minus 2, it gives you what? There we get 10i. And if I subtract these, 2ia. Subtracting these gives me, the 1's cancel, but the 2ib. Of course, we can cancel out the I, right? And then if I take the, I mean, by now, of course, you guys could have solved and substituted. I just like adding equations. How you do the algebra is your business. I'm just doing it a way. I'm not saying it's the best way necessarily. In fact, I'm pretty convinced that a non-complex root is better for this problem at this point. 4b, so therefore b is what? 3. And we also know that 1 is equal to minus a plus b from equation 1 plus 2. Therefore, a, b minus 1, which is otherwise known as 2. All right, so finally, we have that the integral of x squared plus 5x plus 2 over x cubed plus x squared plus x plus 1 dx is actually equal to the integral of what? Let's see, collecting our thoughts. I have 2x plus 3 over x squared plus 1 minus 1 over x plus 1. And then I can integrate using the techniques we went over last class. In particular, this is the natural log of the x squared plus 1 plus 3 inverse tangent of x minus the natural log of the absolute value of x plus 1 plus a constant. Indeed. What happened to the 2? Any ideas? How did I integrate 2x over x squared plus 1? What did I make? I made a u equals x squared plus 1 substitution, right? So du is 2x dx. So the 2 is part of the du. So that's basically it. Yeah.
Does this technique of like using the have a name? Or...
I guess it's algebra. I don't know. I mean, it's not named after Pac-Man. I know that much. I mean, you can do this. I mean, anytime you have an irreducible quadratic, right? Some quadratic which doesn't factor, it has complex zeros, right? So whatever you can do for real factors, you can do for complex factors if you're willing to work with complex numbers. Is it the best way? I don't know. That depends on your comfort level. You have to decide for yourself whether it's the best way for you. I mean, the other way to do this problem, can I erase this? Show you the other way? Right quick? Reasonably quick? I actually think for this problem, I'm not so convinced it's useful. I mean, doing some complex arithmetic, especially for those of you who are electrical engineers, you already had that, right? Okay. Is wise because you guys will work with imaginary numbers. Now, you guys tend to use I equals to j for some reason. Apparently I is current or something, I don't know. But the other way to do this, of course, would just be to what? You feed Pac-Man minus 1. That much is the same. I shouldn't erase that. That's still going to give me what? Minus 2 equals to 2c, right? So we still get c. I mean, that much everybody agrees that that's the wise way to go there, right? And then past that, I suppose you could say Pac-Man is equal to what? X squared plus 5x plus 2, but it's also equal to what? Multiply it out, right? I guess, or don't multiply it out. How about that? Forget that. Let's just think about it. How about the coefficient of x? What was that? Have you collected your daily arena reward? You know, I gotta make these stupid things stop texting me. Like I get these games for my kids, and then all these stupid games are like texting me all the time. It's very annoying. The Angry Birds, and the, you know. All right, anyway. Coefficient of x. On the left-hand side, you got 5, right? On the right-hand side, equating coefficients. What is the coefficients of x over here? How about 1 times ax? There's an a, right? There's a b. Anything else? There's a c, right? Now c is minus 1. So we can rewrite this as 6 is equal to a plus b, right? See x squared plus 1? Oh, there's no x. I'm sorry. Oh, yay. Thank you. Thank you, thank you, thank you. See, you guys understand. This is very encouraging to me. X squared. We've got a 1, right? I didn't, excuse me. 1, oh, I'm an idiot. Yeah, no, x squared has a coefficient of 1. It's right here if you look at it. See? We got a, right? A times x, n plus c. But that's what? A minus 1. Therefore, a is equal to 2, right? And if you take that and you go back up here, what do we get? Sorry, not the greatest labeling, but what did I say? B equals to 5 minus a, which you just told me was 3. Okay. So yeah, I think that's easier than the complex thing I did, right? I'm just telling you there are problems where the complex thing, what? You guys don't want to learn complex arithmetic?
Are there times, like, I guess it's just that, like, spreading it out would just be too difficult, so you just use the complex? Or?
I'm just telling you that you can plug in complex roots and simplify these equations as well if you're courageous. It may or may not be helpful. Another example. Integral of, I don't know, x squared plus 3 over x minus 2 quantity cubed. All right. This is a better example to showcase the differentiation thing I was doing. So we'd have what? X squared. Actually, I'm running out of time, right?
You got like 8 minutes.
8 minutes.
You can do it, yeah.
I can do it. X to the 5th plus x cubed. Oh no! All right, so x to the 5th plus x cubed. I have to divide that by what? What's x? So 1, 1, 1, 1, 1, 2, 1, 3, 3, 1. So that gives me x cubed minus 2x squared plus, 2 times 3, 6. 6 times 4 is 24x minus 8.
Oh, yeah.
No? What'd I do?
Wait, where'd the 8 come from?
Because we're doing, if you have a plus b cubed, you get a cubed plus 3a squared plus 3a squared b plus 3ab squared plus b cubed. So I'm taking a equals to x and b equals to minus 2. A little bit of algebra. Oh, that should be 12x? Thank you. Are you sure about that? Because b squared is 4. 4 times 3. Oh, 4 times 3 is 12. Yeah. Okay. All right. I'll allow it. Okay, and then this gives us what? X squared? X to the 5th minus 6x to the 4th plus what? 12x cubed minus 8x squared. Right? And then I have to do long division first here, right, guys? That gives me what? 6x to the 4th minus 11x cubed plus 8x squared. I regret my life. Plus what? 6x. Yeah, 6x to the 4th. Oh, minus 36x cubed. Ooh. Plus 72. I can do it. Thank you. I appreciate your vote of confidence. Minus 48x. That gives us a headache. 25x cubed minus 64x squared. plus 48x. If you tell me there's an error up at the top of this, I'm going to kill you. Is that good? Can we go further? Oh, yes, we can. Plus 25, right? So I've got 25x cubed. Oh, goodness gracious. Minus 150 x squared. 300. Oh. Plus 300x. Minus 400.
At least you can take out 25.
Oh, 200? Oh, yeah. Sorry. I can't do math. So then at least we're done now, right? So this is what? Is that 86?
Oh, no, you can't take it.
86x squared minus 252x plus 200. Yay. All right, so this is equal to x squared plus 6x plus 25 minus 86x squared plus 252x plus 200 divided by x minus 2 quantity squared, cubed, rather. Now we can do partial fractions on the cube term. Still have time. Dang it.
No, we don't.
Fine. So minus 86x squared plus 252x plus 200 divided by x minus 2 cubed is equal to a over x minus 2 plus b over x minus 2 squared plus c over x minus 2 cubed. So what we get is Pac-Man is equal to minus 86x squared plus 252x plus 200, but it's also equal to a times x minus 2 squared plus b times x minus 2 plus c. Feed Pac-Man to, feed Pac-Man to, and he has indigestion. I don't know, minus 86 times 4 plus apparently 504 plus 200 equals C. What?
You mixed up some negatives. You had, it's supposed to be positive 86 and negative.
Where?
Oh, yeah, it's positive 86 and negative 252.
Oh, I'm sorry. Yeah, that's supposed to be a plus. Why did I write a minus there? I'm an idiot.
And then negative 252. Wait, why is it? Don't you subtract the remainder?
No, you had the remainder. Yeah. Okay, so that's easily fixed. Stick with me, guys. d Pac-Man dx is what? 2 times 86? 172, x minus 252, and that's equal to 2 times a times x minus 2 plus b, right? So therefore, if you feed Pac-Man prime to, what do you get? You get 172 times 2 minus 252 is equal to b. And if you look at Pac-Man prime prime, 172 is equal to 2a. And so, therefore, a is equal to 86. And while the numbers are obnoxious, you can easily see that we've just found b and c modulo some arithmetic I'll mess up because I'm hurrying. Do you see the idea? I mean, so when you have just one repeated factor, these problems aren't that bad. What made this more awful was the problem you asked me about at the start. Not only had a repeated factor, it had something else. And the something else results in product rules. And it gets all mixed and intertwangled and just nasty. This is an appropriate quiz problem. The thing I did at the start of class, I can ask like one of those, that would take half the time, right? This problem, once I get rid of these annoying big numbers here, shouldn't take that long after you've done a little bit of the homework, right? But anyway, I shut up. Oh, I got your quiz for you. I know the scores are a little bit low. I'm hoping that they improve. Yeah, they're a little low. You can cut the camera off. 'Cause I don't want to name names.